Hi guys, today we're going to talk about how to formulate a system of linear inequalities. Okay, so we're going to be looking at word problems and we're going to formulate equations or actually inequalities to represent a shaded region. And then we're going to be able to talk about how do you find a solution in that shaded region. Okay, so let's go ahead and get started. And yeah, let's see what happens. So here in this example, right, I'm going to show you how to approach this setup. Move this out of the way so you can see it. Okay, so the student fun club plans to go to the movies. At the matinee, tickets cost $6 and popcorn. Sorry, $6 and popcorn costs $3. There's the evening show, there's a matinee show, and there's different expenses for each, right? Notice how here the fun club attends a matinee, right, and spends less than $60, and then attends an evening show and spends less than $36. So which of the following of these is a solution for the number of tickets and popcorns purchased? So what we're going to do is we're going to create a linear inequality system, and then we're going to figure out which one of these options fits these two categories for us to figure out like the total cost of the ticket and the popcorn at the same time. So let's go ahead and get started by the system of inequalities. We're going to highlight the important things here first. So I'm going to separate these into two parts. The matinee showing, right, and the evening showing, because those two are going to have different costs. At the matinee, tickets cost $6 and popcorn costs $3. Notice how also it says here that the fun club attends a matinee and spends less than $60. Those are going to be the key words that I'm going to be looking for this particular problem. Okay, now that's for the matinee linear inequality. In a little bit, I'm going to do another one for the evening show, and I'll walk you through that one. So we know that the tickets cost $6 and the popcorn costs $3. Let's just label our inequalities real quick. We're going to label X to be the number of tickets. And we'll talk about Y representing the number of popcorns. So whenever we talk about these two variables, right, number of tickets and number of popcorns, we're talking about for both the matinee and for the evening show. So let's get going. For the matinee show, right, $6 per ticket and $3 per popcorn. So that means we're going to do 6, I'll do some blue. We're doing 6x plus 3y. The reason why I'm using x and y versus t and p as a variable is because I'm going to put this in Desmos in a little bit, and I want to be able to use x and y as a variable. Now, the key word here is that it spends less than $60. So we're going to use the less than symbol, $60. That's my first inequality. We'll graph it in a little bit, okay? The next one is talking about the evening show. So at the evening show, the tickets cost $9 and the popcorns are $4, right? It's more expensive. And at the evening show, we spend more than $36. So we're going to create a different linear inequality for this one that's in red. And I'll keep it in red so you can see the difference. So the tickets cost $9 each, so 9x. The popcorn costs $4 now. And we know we're spending more than 36, so greater than $36. This is my linear inequalities that I'm going to be using for my system. Now I want to figure out which one of these options, right, fits both of these systems. If I spent less than $60 in the morning and if I spend more than 36 in the evening. So let me show you real quick here with Desmos and how that's going to work. Here on Desmos, I'm going to type in the equations as 6x plus 3y less than 60. And then my next equation is 9x, sorry, my next inequality is 9x plus 4y greater than 36. All right, now that I have this one, I'm going to make this a little bit bigger so we can see. Let's close this out, move things around. Remember, we're focused on the shading area that overlaps. So not the blue section, not the red section. We're interested in the part that they both have in common. This is where our solution set is going to exist, in between those. Now, I know I can't have negative number of tickets and negative number of popcorn, so I'm going to shift this over so I can just focus on the positive section of this graph. And then all I have to do is go through these scenarios and which one of these is going to be in this shaded region. So what I do is I'm going to first convert these to ordered pairs. 2 tickets and 4 popcorns really means 2, 4, because X represents the tickets and 4 represents the popcorn, right? My X and my Y. This represents 3, 2. This represents 7, 5. And this represents 9, 3. So we're going to plug in these points and we're going to test out to see which value is in this section. And we can actually do that here. We can even do that here by typing in the point. So for answer choice A, we have 2, 4. I'm going to put the label as A. Answer choice B is 3, 2. I'm going to label that B. Answer choice C is 7, 5. And the last answer choice is 9, 3. All right, so if you notice here, we have D is on the outside, A is on the outside. Let's zoom in a little bit. We can see some clarity. They're all going to lie on the outside except for C. C is the location or the value. Let's highlight this in yellow or green, even it stands out probably better. C is the only option that works for both scenarios, the matinee and the evening. Okay, so even if these we're landing on the line, remember, because this line is dotted, it's not included. Line is dotted, so none of these are going to be included. C is right in the middle of it, and that's the solution. In order for you to be able to spend what this says here, in order for you to be able to spend less than $60 in the morning and more than 36, we got to be able to buy 7 tickets and 5 popcorns, and that's how you stay in the range of both situations. All right, guys, I hope this helps. Remember, there is also a recording in class for the live session, and yeah, I'll calculate later.